The human mind, the human brain. For my entire life, I've not stopped thinking about mind and brain. What do they do? How do they work? How did they happen? I start with the two basic activities that minds and brains do. They think, which is called cognition, and they feel, which is called emotion. To me, to all of us, thinking and feeling, cognition, and emotion are ordinary, everyday stuff. Yet, when I pause and ponder afresh thinking and feeling, in a context of a vast cosmos of forces and fireballs, gases, and rocks, I am astounded. What mechanisms underlie thinking, cognition, and feeling, emotion? How do human cognition and emotion compare with that of other animals? A unifying key, as in all biology, is evolution, the magic of apparent design. How did cognition and emotion evolve? I'm Robert Lawrence Kuhn, and Closer to Truth is my journey to find out. Cognition and emotion have long taken my breath. And while I've explored both, first via neuroscience, then via philosophy of mind, I've remained unsatisfied in comprehending the startling incongruity of cognition and emotion appearing in what seems an oblivious mechanistic universe. Recently, I've come to see the explanatory power of philosophy of biology, a novel way of thinking about biological phenomena, and a fresh way to apply evolutionary understanding. Philosophy of biology stresses precision of terms, clarity of argument, and foundations of concepts. I begin with a philosopher of biology and of mind, an expert on adaptations in evolution and on the mental life of octopuses, Peter Godfrey-Smith.
Within a Darwinian picture, things happen gradually. You don't tend to get jumps, you don't tend to get really sharp discontinuities in the evolutionary process. But in the area of the evolution of the mind, in a Darwinian context, you expect a lot of gradations. And I think that people, both within philosophy and in everyday settings, have often tended to assume there are sharp divides. You know, these guys are conscious, these guys are not. And somehow, as Darwinists, we're going to have to get used to the idea that probably none of those distinctions are sharp. And the place where this gets really interesting is when we're thinking about very simple forms of cognition in simple animals, in organisms like plants and fungi, even in bacteria, there is sensing in these organisms, and there's responding to what you sense. There's memory in many cases, but even bacteria have a tiny glimmer of what you might call short-term memory. And somehow we're going to have to develop a picture of the mind in which we can make sense of these cases that mind seems to be neither wholly present nor wholly absent. And I think that philosophy of mind and philosophy in general is more or less forced to grapple with something as a consequence of the Darwinian picture.
How controversial is that? Are there biologists, neuroscientists, or philosophers that argue for a more punctuated equilibrium approach to this?
Definitely. There are lots of people who think that there are sharp divides in this area. I remember there was a conference at NYU a few years ago where I said about how Darwinism forces us to think about consciousness in particular as something that won't be a sort of simple yes or no matter. It has to be something that comes in degrees. A lot of people at the conference, it was a philosophy conference, just thought that was impossible. It doesn't make sense to think of consciousness as something that could be sort of half present, half absent. There has to be a line somewhere. Similar views have been expressed in relation to various kinds of cognition, in language. In all these cases, I don't think that sharp divides are flat out impossible, but we're pushed towards a more gradualist view, I think, by the Darwinian framework.
Peter has mind, cognition, and emotion developing very gradually, with rudimentary mind, rudimentary cognition, rudimentary emotion in even the simplest single-cell creatures. A philosopher seeing slow gradients, not sudden steps. What evidence would support such gradualism in the evolutionary development of mind? Could comparing diverse species help? I ask a computational biologist, Joshua Swamidass.
The place where science can really add a lot of information is really the comparative work of looking at the cognition of other animals. A lot of people think that we're the only people with a sense of morality. But the fact of the matter is that there's like really good experiments where you can show like primates have a sense of fairness. And it's a fairness that doesn't just apply to themselves, but they really want other monkeys to be treated with the same fair sorts of rule. I wouldn't try to equate it with Kant.
Right.
It's not the same thing, but it is close enough to be surprising. There is a sense of right and wrong that they can't have, and a sense of indignation, things that are unfair. And that's important. I mean, that's something that kind of tells us that this might have a lot more deeper roots, and it might be something that might have been there before the things that are more uniquely us arose. Those sorts of things are places where biology really can add a lot to the conversation by giving us, in a lot more precision and in detail, understanding of how these other sorts of animals on Earth actually think and conceive things about the world.
Joshua looks to comparative psychology and surprising mental and behavioral similarities between human and non-human animals to probe the origin and development of human cognition and emotion. But which species count? Primates only? Mammals and birds only? How far down the phylogenetic ladder can the evolution of cognition go? I explore with a philosopher of the natural history of mind and of human evolution, Rachell Powell.
The paleontologist Stephen Jay Gould famously says, if you rewind the tape of life and you play it again, you would get a completely different shape of animal life. His argument was sort of focused on bodies, but it's really the idea that you reran the tape of life again, it's unlikely that vertebrates would have survived, and as a result, there would be no complex cognition, consciousness, and other kinds of properties that we associate with complex intelligence. And I think, there's been a lot of pressure on that argument coming from this phenomenon of convergent evolution, the independent replication of similar biological forms and functions, to see that the initial conditions that are resulting in the same outcome. So if you're starting with something like mammals, and then they diverge into a bunch of different groups with extraordinary intelligences, as they have for like whales and dolphins and primates, they're still starting from a very rich cognitive platform. If you really want to show the deep replicability of mental properties, you want to see the evolution of minds from radically different starting points, okay? And that's where invertebrates come in, like mollusks and arthropods, which include insects and crustaceans and spiders and millipedes and so forth. These animals share a common ancestor that was brainless, eyeless, was not an active organism. It was essentially like a relatively undifferentiated worm somewhere around 600 million years ago. And yet independently and in rapid succession, they evolved complex forms of sensory modalities, complex image-forming sensory modalities in those three lineages through vision. And then that sort of through a feedback process interacted with the evolution of information processing capacities, namely brains, and also active bodies at the same time to create these extraordinarily agentic lineages that we see today, and sort of in a ratcheting effect ends up creating minds.
So what's the implication?
Since they all evolved those states, these centralized nervous systems with complex behaviors, the implication is that very different starting points will lead you to the same outcome.
Different starting points lead to similar outcomes, especially regarding minds? It's Rachell's blunt challenge to conventional wisdom and evolution. So if there are different evolutionary paths, all leading to mind, cognition, and emotion, what are the evolutionary drivers? I ask a pioneer of heart electrophysiology, a founder of systems biology, a noted contrarian, Denis.
I'm a physiologist. I know that our nervous systems, brain in particular, consumes a huge amount of energy. Now, what evolutionary process would allow that to happen if there wasn't a really major advantage? And the advantages are obvious. We can anticipate the behavior of predators. And if we are predators ourselves, we can anticipate the behavior of prey. We are thinking. It seems to me these are processes that align our bodily processes to fit with all of our social interactions. That seems to me to be not a bad way of saying what the mind is. What nervous systems are extremely good at doing is producing a vast number of anticipatory scenarios. And that is the process we're so good at as humans, but I think the big apes certainly do it. I think my cat does it. I think that even probably a bacterium does it to some degree. And what I think is the breakthrough is going from the ability to have limited variability in what we can do to the ability to have almost unlimited possibility of associations. Our language illustrates that beautifully, as it were jumping out from being just the physical body one is to the world of ideas. That's what gives us the ability to have insight. That's what gives us the ability to anticipate successfully. And if you study the organisms we have today and ask which of those that are capable of doing this unlimited associative learning, as we can call it, the possibility of almost endless combinations, as our language has shown. In other words, to be conscious of everything that's happening around us and to be able to integrate that into anticipatory action.
To Denis, generating a very large number of anticipatory scenarios, especially in humans exploiting the vast flexibility of language, adds a new dimension to mental development. But what are the brain mechanisms and how did they evolve? I ask a neuroanthropologist who explores the evolution of human cognition and emotion by distinguishing human brains from other mammalian brains, Terrence, Deacon.
Brains evolved for bodies. The primary business of cognition is not to think about stuff, but to keep the body going. In fact, one of the things that we're learning now, how coupled metabolism is with brain activity, for example. And because of this, what we realize is that what brains are doing is not just processing information, but they're processing information in a way that's entangled with their own metabolism in complicated ways. In fact, we've got a study currently underway in which we're actually looking to see if changes in metabolism are actually in process of changing thought. So when I try to initiate a new thought, is it because I've actually sucked down the oxygen and glucose in one area and driven it up in another area? What it means is one part of the brain can control another part of the brain by doing so through metabolism or by changing neurotransmitter levels and things like that. So in that respect, the physical nature of cognition is critical. That what's actually going on is cognition is about feeling. And we can then, in a sense, superimpose other stuff on feeling. In this respect, it also leads us to something that artificial intelligence and computing technology does poorly, and that is help us understand emotionality, feeling. We confuse feeling with sensory input, but in fact, everything I do has a feeling to it. Now, the base emotions are tied to what's going on with the body. Is it dangerous? Is it troublesome? Is it ruining things? Do I need something? One of the interesting things about being human is that we have access to a whole variety of emotion and emotional states that I think other species minimally or never have an ability to get in touch with. And I think that's because of our symbolic abilities. Because symbolic thought can put together ideas and experiences and possibilities that are, might ordinarily not come together. One of the things that we do is that we tweak emotionality symbolically. What symbolic representation? It's allowing us to juxtapose and entangle emotions in ways that could not have been done without this. One of my favorite emotions in this respect is nostalgia. Think about the juxtaposition that's there in nostalgia. Positive emotions, negative emotions, the present, the past, the possibility, the impossibility. Yeah. They're all juxtaposed, and it has a very distinctive feeling
it does.
To it. We know what nostalgia is like. I think the eureka experience. I discovered something, learned something new. That's how ideas do that for us human beings. I think the one that we take for granted, but I think is also unusual, is humor, getting a joke. Yeah. Why should a logical twist produce this very distinctive emotional state that produces a very distinctive vocalization with it? One of the things about tweaking our emotions and generating what I call novel emergent emotions, emotions that wouldn't have happened otherwise, is because we have this joy of exploring that space and finding new kinds of emotional experiences.
Terry's argument goes like this. Brains evolved to serve bodies. Mentality relates to regulating metabolism. Cognition is about feeling. Moreover, symbolic capacities are critical, enabling emotions to be tweaked and fine-tuned. But what's the significance of emotions in mentality? Are emotions derived from cognition? Or are emotions more than cognition's junior partner? I ask a philosopher of theoretical biology, whose initial focus was on theories of emotions, Paul Griffiths.
I wrote my PhD on the emotions, and when I started out, I thought, emotions are really special because they're really important in behavior. They make you do stuff, and yet surely they're essentially conscious. You've got to experience an emotion. So, hey, maybe I can solve the problem of consciousness if I get a really good understanding of what emotion is and how it works. And I started reading all of the science, the neuroscience and the animal behavior people and the anthropologists. And I realized that consciousness had very little to do with it. And so by the time I came to write my first book, which was called What Emotions Really Are, it purported to tell you what emotions were while saying absolutely nothing about consciousness. And I came to think, of course, as human beings, we know that we consciously experience emotion, that it feels like something to be angry, it feels like something to be irascible or to be depressed. So emotions are really important for cognition and motivation. They're really important for physiological activation in other parts of the body. They're really important when understood as strategic interactions between social interaction partners. And if sometimes those things happen without any conscious experience. And if we take the conscious experience away, sometimes they happen without being expressed in overt behavior. So I no longer think of emotions as essentially conscious. I think the most interesting thing to study about emotion is what emotions do for you as actions. So getting angry is interacting with somebody. You can, if you want, see it as a negotiating strategy. It's what biologists call strategic behavior. But also, taking an evolutionary perspective on emotion is a matter of thinking, how do emotions figure in human life? So how are emotions functional as part of our existence as a successful organism? And so I think emotions as ways in which we manage our social interactions. I think there's some very powerful attempts to understand the moral emotions as moves that people make in interpersonal social games. And that's very much an evolutionary perspective. When somebody gets angry, an evolutionist is always going to ask, will getting angry diminish or reduce that person's fitness? And if it's reducing their fitness, they'll be puzzled. How could doing something regularly that reduces fitness have evolved? So they'll look around for some way in which having that emotion is functional, is achieving something in the longer run.
You got me intrigued. In anger that doesn't improve fitness, what is the evolutionary reason it's there?
There's the notion of emotional intelligence. Emotional intelligence is the ability to have the right emotion at the right time. And if we look at, say, primate models of this stuff, when you mess up the social development of a primate by, say, depriving it of maternal affection, whatever it might be, you end up with adults who can't function effectively in society. They'll get themselves driven out of their troop. So you can think of normal biological development as including the development of the ability to have the right emotion at the right time to manage your social relationships. And so I guess that's my...
To Paul, emotions empower actions, especially interpersonal, social actions. Emotions enhance fitness for evolutionary selection and success by enhancing emotional intelligence. Is there evidence for this kind of evolution of emotion? Can emotion be traced in the archaeological record? I ask a philosopher of cognitive science and of religion, whose first PhD was in archaeology and art, Helen de Cruz.
Oneness is such a great topic in many religious traditions. And my starting point in this is that you have all these really sophisticated philosophical ideas about oneness, but ultimately they find their origin in experiences. So at the most sort of parochial level, you could feel one with your family, or you could feel one with your broader community. You could feel one with the whole of humanity.
Can you in any sense trace that in an evolutionary way in terms of the archaeological record?
I think you can see oneness in an archaeological sense, in that particularly Homo sapiens, it's been a marked feature of them. So if you look at, say, the African Middle Stone Age, so around 100,000 years ago, then you can see how people lived in small groups, and you can't really feed a whole lot of people on a sort of hunter-gatherer diet, but they would regularly come together and they would have like partners, friends, relations. And you can see that even in contemporary African indigenous societies or recent societies, such as like the Sharo system among the Yuhuanzi Bushmen. So you can see it in the archaeological record how you have all these tools, these refined tools, and you can see them sort of spread, and you can see them spread from far away from their origin. You can see in the Levant things like seashells of like 100 kilometers away. Like how did it get there? Well, it got there because they were interconnected. So being interconnected, we tend to think of this as something recent, like globalization. But actually, you know, if you look at history even, there have been many periods in which we had a more sort of cosmopolitan way of being interconnected.
To Helen, the sense of oneness or interconnectedness, as seen in diverse traditions and traced via archaeology, tells an evolutionary story of cognition and emotion, though I worry when evolutionary stories seem just so. I should get a skeptical view. I engage a philosopher with a pluralistic view of science categories, John Dupré.
There are so many aspects to human cognition, and human cognition is so deeply intertwined with the environment that we have created, and which is both the subject of and part of the means of our cognition, that I think it's very hard to know what kind of story to tell. But I don't think we really have a very clear story even of the facts of the history.
Is that why you've been a critic of evolutionary psychology?
The problem with evolutionary psychology is it's an almost grossly simplistic account of human evolution. It's not always explicit, but given the assumption of the application of traditional, standard, genetic-based models to human behavior, it's committed to some way in which the genes essentially determine behavior. If it's saying that we can understand behavior better by looking at genetics and the evolution of genetics, then I think it's grossly simplistic, because I think that human behavior, human development, human evolution are all multifactorial processes.
Cognition and emotion, thinking and feeling, form the foundation of mind and mentality. Philosophy of biology provides diverse perspectives. Cognition evolved gradually. Even single-cell animals have rudimentary minds. Comparative behavior and psychology of human and non-human animals shows similar traits, thereby elucidating the evolution of cognition and emotion. Invertebrates offer an independent starting point for mind, showing that cognition and emotion can evolve along different paths and can converge. What's needed for human mentality are innumerable anticipatory scenarios and the flexibility of language. Brains evolve for bodies. Mentality regulates metabolism. Cognition is about feeling, and symbolic capacities are critical. Emotions empower actions. Emotions enhance fitness by boosting emotional intelligence. Human interconnectedness, found in archaeology, evidences the evolution of mind. Evolutionary stories are too simplistic. Human mentality is multifaceted. To sense mind in any living creature, to know human mentality in all its complexity and richness, cognition and emotion bring us closer to truth.
For complete interviews and for further information, please visit closertotruth.com.